Thank you, sir.
Of course.
I wanted to ask you if time can really be defined because time here is different in other places is different. And it's also said that when we go outer space or out of the earth in the space, the time usually it is slower than how it is going right now. The pace is very slow. And also the traveling of light years. We people say that if they travel light years, then the time is actually very different. And if they come back to the earth, then they would like not age, but the others would get older like that. So like, what is exactly time, and how can we define it?
So that's a very good question. Time is very shaky with with the theory of general relativity, but essentially we can define time through what we call proper time. So this is basically, it's too complicated to explain in full, but this is basically the time that you perceive to be around you. And first of all, we only perceive different times around the world because our time is in respect to the sun rising and setting. So, for example, on the other side of the world right now in the US is all the way over here, say, so like this. And right now, the sun is on the other side. In the U.S., it's already night. So, since sunset has already occurred, and sunset occurs earlier for them than for us, where we are right here, since our time is with respect to sunrise and sunset, that means right over here it's going to be 6 o'clock or 7 o'clock. I don't quite remember. While right now, it's about over here in India, it's about 9 a.m. Now, in terms of relativity and traveling in space, time does get distorted, but proper time is essentially the time that we perceive in our own reference frame. What that means is if we have a stopwatch attached to ourselves, proper time is essentially the time that the stopwatch will display. So, that means that for each and every person, their time is actually different. But time in general is perceived the same way by all of us. Now, we can't actually perceive this effect ourselves because, I mean, the fastest speeds that we can travel are very small in comparison to light. But we have tested the theory of general relativity through other means, and it has been proven to be true. So, I believe that a proper time is a correct construct, and essentially, it's based off what we call the space-time interval. Although I think I'm getting a little bit too in-depth right now, so we can stop around here. So, this is essentially how proper time works. This right here, ds squared, this is just what we call an invariant, a value that never changes no matter where you are, what reference frame you're in. This is just time multiplied by the speed of light, and this is proper time. So, yeah, that's essentially it. Oh, actually, never mind. I'm pretty sure it's just this. Yeah, there we go. So that's essentially what time is and how we define time. It's just local to our own reference frame every single time. So that's it, and thank you for the question. It's very in-depth.
Thank you so much for answering. I'm very thankful that you answered my question.
Of course.
What do you mention?